Okay, in today's video we're going to look at setting up a phased array sweep, and we're going to look at the probe configuration and the UT beam set objects. So let's start in the acquisition manager, and we will add a simulated A-scan. We're going to look at the properties and change the channel type to phased array. Does some changes, and then we're going to drag this create sectoral beam set onto the inspection manager, and we're going to create a sectoral beam set. So let's put this over here and do 35 degrees for 70 degrees, and we'll execute that. And you see that we've got 35 to 70 degrees, and we've got a raw sweep here. I'm just going to right click and add a sweep correction node. We'll drag that out and just remind you what we're looking at. So we've got a phased array sweep. So physically we've got a probe sitting in this area up here, and it's firing 35 beams in a sweep here. And those beams change from 30 degrees to 70 degrees, and we cover this area. And this is remap this area into a Cartesian physically correct XY space. And that's what we're doing, and obviously there's a lot of math and information you need to do that, and let's have a look at where that is all living. So this object here is called a probe configuration, and let's look at its properties. And its properties show us that it's got three basic parts to it. Or two basic parts: the probe, which is made up of a transducer and a wedge, and then also a bit of information about the part and where we are sitting on the part. And so that's really the probe configuration is exactly what it says, is what is the probe and a little bit of where it is, what part is sitting on, what's it made of. So that's the big picture on that one. And then the UT beam set is this object here. We look at its properties, and the guts of it are as follows. We've got a description of what this sweep is, and then underneath we have details of what is being done. So in this case we say we've got a sectoral sweep, which basically means you've got a bunch of beams that are changing in angle from 30 to 70 degrees. We are firing 16 elements, and it gives us 35 beams. We're saying we're using a shear wave here. And then if we look into the details of the beam, so this is the current beam, and this is the selected beam is the current beam. And we go under the hood here, we go down a tab, and we see that this beam is at 35 degrees, no skew. Now this x-axis here, what that means is I am shifted 0.5 millimeters from our datum point here, so that's where this is entering, and it's going at 35 degrees. And it tells you the elements you're using, and here it tells you the delay on those elements. So that's your phasing to steer the beam. It also tells you there's an interface delay, that it's taking, it's 95 nanoseconds delayed there, and then we can, I'm just going to go back to change our current beam to, let's change 30, so one of the later beams, and you can see the angle has gone up to 65 degrees. Our x offset is 13 millimeters. Our delay has gotten quite a bit bigger. And if you notice that the phasing has changed, it's up to almost 2 microseconds on the outside element of phasing. And so these are the details, and you have one for each beam. And to let you know what's going on under the hood here, that's how we're drawing this plot here. The delay is used to shift the A-scan up and down. The angle, obviously, you're drawing this beam at 65 degrees, and you're offsetting in X, so that's how come these are not all in the same place. So again, just back to the big picture, the UT beam set contains a description of the beam, of the sweep, so the pattern that it follows, whether it's changing an angle, whether it's changing position, whether it's rotating around, changing a focal length. It describes the pattern, and then the beams, in this case the 35 beams, will be an implementation of that. It'll say, how do I get to 35 degrees with these delays? How much do I have to offset my time so that it lines up with the other beams? How much do I offset my position so that it draws correctly in space? So these are the details, and these change depending on your sweep. Okay, so that's an sort of a high-level description of what's going on. To review, the probe configuration describes not only the probe, the transducer, and the interface, which could be a wedge or immersion, and then the sweep is what beams are generated by that transducer, that probe. Okay, so how do we did this step at the beginning where we make the sectoral beam set, and that is a task. To remind you, under here, create focal laws, I use this task. This is, let's pull this one out. We can do a linear beam set and follow how that works. So basically what this does is, this is the description. So remember, the beam set, the first part is the description of the beam. So we've got this description in here, and what it does is it fills in this description, and then it goes under the hood, runs the focal law calculator, goes and gets the probe and asks the question, if I want to run from these elements, these 16 elements that I'm running, and I want to run a beam at 35, 36 degrees, what delays do I need to put on my elements? How does this, where will this enter the part? So how do I have my X offset? What times does it need so it lines up with the part? And it fills all this out. So this does all the work here of filling out the beam set. And of course it has to go to the probe, because these are all physical calculations, looking at the wedge thickness, looking at the velocities in the part, and so on. And so these are all tied together. But that's the general pattern. So let's just, for fun, we'll go and I'll put this over here. So this is going to calculate a linear beam set. I'm going to put it to 45 degrees. I'm going to make my aperture 8. I'm going to make my step by 1, and I'm going to say use all the elements, and we'll run this one. And you can see now our mapping into space has is sort of a linear movement across time at the 45 degree angle. Go back to this one, and it's covered a fan shape. And hopefully you can see what's going on under the hood. It's a implementation of this description, going to the physical setup described in the probe configuration, and calculating the details on the details of the 35 or how many ever beams it is, and pulling them all out. And then what we're left with is enough information that we can, number one, fire the transducer so that it behaves in this way, and number 2 so that we can draw it. Okay, so I think we'll leave that there. That's an overview of what we've done, of the probe configuration and the beam set, making a phased array sweep. And perhaps we'll do another video that's got more details on the contents of these two objects.